Good morning all of you. We are doing physics, class 7, physics, chapter number 2. We have completed chapter number 1. Today we will start chapter number 2, physical quantities and measurement. This chapter today we will start. So what do you mean by measurement? Measurement is the act of determining the magnitude of a physical quantity with some known physical quantities. Okay. Suppose that we are measuring something. We have gone to a shop and buy some sugar. So we will tell the shopkeeper that give me 1 kg of sugar. He will measure with a physical balance by putting a weight of 1 kg in one pan and by putting sugar in another pan which is equal to 1 kg. That means he has a physical balance and a weight of previously described 1 kg, and he will equally give that amount of sugar to you. So it means that he has determined the value of the previous physical quantity which he has already have. Okay. Now in previous classes you have learned that the act of determining physical quantities such as length, area and mass, volume of solids and liquids, weight of substances, time and temperature we have already read in class 6. Now today we will read density of a physical quantity which can be determined with the help of mass and weight. In this chapter, we will learn how to determine the density of irregular solids and relative density. So, what is density? Density is defined as the mass per unit volume of the substance. So, its formula is density is equals to mass by volume. This one. So, density may be written as rho is equals to mass small m by small v. This is the formula of density. Density may be written as rho. This one is rho. Okay. And mass is small m by volume is v. Now, the SI unit of mass, as we know that kg, and the volume is meter cube. Hence, the SI unit of density is equals to mass, that means kg by meter cube, or we may write kg meter minus 3 to the power minus 3, that is by meter cube. Okay. Now, measuring the density of irregular solid. How we will measure the density of irregular solid? Because we know that how to measure the density of a regular solid by using this formula. Now we have to measure the density of a irregular solid. For that, what we have to do? We have to do like this. Density of irregular solid can be measured with the help of an apparatus called Eureka can. What is Eureka can? And a measuring cylinder. When an object dropped in an Eureka can filled with water, the water displaces through the spout. So, this is known as Eureka can. This can is known as Eureka can. It is having a spout over here. When water is filled up to its spout, if we put anything in the water, then the water will come out from this spout. That is why it is known as Eureka can. And there is a measurement also over there. Okay. Now, when an object is dropped in the Eureka can filled with water, the water displaces through the spout in the can. This displaced water can be measured using the measuring cylinder, which helps in finding the volume of the liquid. So, if we will know the volume of the liquid, then we have to measure the mass of the liquid. After getting the mass of the liquid and volume of the liquid, we may use our previous knowledge from here. We have to use this previous knowledge, and density of the solid substance is its mass per unit volume, that is density is equals to mass by volume. So whatever the mass we will get after measuring the liquid and whatever the volume we will get, then we will get the density of that mass of that irregular solid, where mass can be measured using weighing scale and volume can be known by using measuring cylinder. Now how we will calculate this? To the following activity shows how density of an irregular solid can be calculated. So you have to read this activity number 1. What is the aim? To measure the density of an irregular solid. Materials what we required: irregular solid, that means a stone, weighing scale, eureka can, and measuring cylinder. This one is measuring cylinder, this one is eureka can, and this one is irregular solid. Okay. Now the methods: measure and note down the mass of the irregular solid. First of all, you have to do this one in grams. Pour water into the eureka can until water spills out into the measuring cylinder. Until and unless the water spills out into the cylinder, pour the water till its neck. Now examine the level of water in the measuring cylinder and write down the value. Tie the irregular solid with the thread and slowly put it into the to the bottom of the eureka can. Carefully, the water will splash into the measuring cylinder. Note down the new value of the water collected in the measuring cylinder. Subtract the two values. The answer is the volume of the irregular solid, which can be substituted in the formula below to find out the density. Density is calculated by using the formula density equals to mass by volume, gram per centimeter cube. So after doing this activity, we will get the density of the irregular solid. Now what is relative density? What is relative density? So the density of a material with respect to the density of water is known as its relative density. So as we know that the density of a material with respect to the density of the water is known as its relative density. It is the ratio of density of substance to the density of water. So the formula of relative density is equals to relative density of a substance is equals to density of the substance by density of the water. It is also known that the specific gravity, since relative density is pure ratio, it has no unit, so it doesn't have any unit. That means relative density doesn't have any unit. It is also known as specific gravity, since relative density is pure ratio, it has no unit. The density of water is 1000 kg per meter cube or 1 gram per centimeter cube. So in 1 cubic centimeter, the weight of water would be 1 gram, and in 1 meter cube, the weight of water would be 1000 kg. So it is easier to compare the density of a substance with that of water if the relative density of the substance is known. So we have taken the water as the relative density, as we know the relative density of the water. So it is easy to find the density of that substance. So density of substance is equals to relative density of the substance into density of water. So take an example. So now we will do a numerical problem over here. One numerical problem is discussed over here, so we will discuss it. Find the relative density of kerosene. The density of kerosene is 810 kg per meter cube and the density of water is 1000 kg per meter cube. So we have to find the relative density of the kerosene. As we know the formula, we will use this formula for finding that one. So density of kerosene, it is already given over here, 810 kg per meter cube, and density of water is equals to 1000 kg per meter cube. So relative density of kerosene is equals to density of the substance by density of water. Therefore relative density of kerosene is equals to 810 by 1000. That means the relative density of the substance is equals to 0.81, and it doesn't have any unit. It doesn't have any unit. Okay, because units will be crossed over here. So how it will be crossed? Because if we will write 810 kg per meter cube divided by Q, so it will be crossed, multiplied, this one will be crossed, and the answer will be 0.81. So that is why there is no unit of relative density. Okay, now we will read about floating and sinking. As we know, some objects are floating on water and some sinks in it. Okay, an object will float or sink depends on its density and the density of the liquid it is placed in. The following activity will help us to understand floating and sinking. So you have to read this activity number 2. I will just give you a conclusion from activity number 2, that an object will float on a liquid if its density is less than liquid. Okay, if an object is less dense than that liquid, then it will float in that liquid. Suppose that the density of water is more than the density of wood. That is why wood floats on water. Okay, an object will sink in liquid if its density is more than that liquid. Let us take an example of a stone or an iron. The density of iron is more than the density of water. That is why the iron sinks into water. Therefore, to determine if the density of an object is more or less than a liquid, check if it floats or sink in the liquid. So if anything which would be floating or sinking, we may get the conclusion that if the object is floating, that means it has the density less than that liquid, and if it will sink, then we may got the conclusion that that object is more dense than that liquid. Okay, a liquid substance can also float or sink in another liquid depend on the density of the liquid. Let us understand this with an activity. So activity number 3 tells us that aim to compare the density of cooking oil and water. Material required. What are the materials we required? 2 glass bottles, water and cooking oil. So we need 2 glass bottles, water and cooking oil. Procedure: fill half of bottle with water. First of all, we have to fill the bottle with water. Then pour some cooking oil into it. After that, the oil should be poured into the bottle. Now fill the second bottle with cooking oil and then add water. Observe the behavior of the cooking oil. The cooking oil always floats on the surface of water. When we put water first and then oil after that, it will float. And then in another jar we have done oil first and then water. Again the oil will come to the top and the water will go down. This observation shows us that the cooking oil always floats on surface of water because density of water is more than that of cooking oil. The conclusion comes that the density of water is more than that of the cooking oil. Okay, so and here in context came over here, science in context. The Dead Sea is also known as Salt Sea. It is actually a salt lake bordered by Jordan, Israel and Palestine. High concentration of soil content in Dead Sea water makes its density almost 24% higher than regular water. Because of this reason, anyone can float in the Dead Sea water. Because of this concentration of the salt, nothing will sink in it. Okay, nothing means any person will not sink in it, whether he know how to float or or he don't know, he will float over there. Okay, because the relative density of water is more than the normal water. How much percentage? 24% higher than regular water. So next day we will start from next day I will give some questions to solve, and after that day we will start this relative density bottle and conclude the chapter. Okay, so next day you will do the exercises. I will give some worksheets to do. Till then, goodbye. Thank you.